Today we're going to talk about light and matter. First thing, if you look at the bell ringer, what happens to the illuminance on a surface if a light source were moved 3 times further away from it? Well, we know that illuminance is an inverse square law, so if you triple the distance, what happens to the illumination on that? Well, it should be just 1/9. 16.2, our objectives: define transparent, translucent, and opaque, and then understand the formation of color by addition of light and by subtraction of pigments or dyes. So here we go, 16.2. The word opaque simply means something that can absorb or reflect all light waves that fall on them. Something that will absorb or reflect all light waves that fall on them. So things that are opaque or an example of something would be a person, a brick, a chair. You know, if it's opaque, no light goes through. It's just absorbed or reflected. Transparent describes things that allows light to travel through them. So a transparent substance is something that transmits light waves. Some examples of transparent would be, obviously, a transparency, something you stick on an overhead. Contact lenses are transparent. Air is transparent. Glass is transparent. Translucent, so those would be examples. Translucent is something that transmits light waves, but not such that you can see them clearly. So an example of this might be a frosted light bulb. Shower glass. Some shower glass is transparent. Most is translucent. You don't want to be able to see the image on the other side of the glass. These plastic covers we have over our fluorescent bulbs in the school are translucent. A spectrum just describes the ordered arrangement of colors from violet to red. And to remember that, we use the guy's name, Roy G. Biv. Stands for red, orange, yellow, green, blue, indigo, violet. That is the order of the spectrum from low energy to high energy, from low frequency to high frequency, or from high wavelength down to low wavelength. This chapter deals with light, so we want to talk about the primary colors of light. Some people get this confused because they grow up so much with art class and they have primary colors there. Those are your primary pigment colors, not your light colors. So the primary colors of light are red, green, and blue. If you look at these new high-def TVs, if you connect one device to a TV without using an HDMI cable, you'll have a jack for a red, green, and a blue, because those three are all you need to make any color of light. And if you mix those three completely together in the right ratio, right intensity, you'll get white light. Secondary colors of light would be yellow, magenta, and cyan. And these are formed by mixing two primary colors. For instance, if you mix red and green, you will make yellow light. If you mix green and blue, you will make cyan. And if you mix red and blue, you will make magenta. So two primary colors of light will come together to make a secondary color, and those secondaries are yellow, cyan, and magenta. The word complementary typically means to complete something. My wife is complementary to me. She actually completes me. She is good at things that I'm not good at. English, conversation, things like that. I'd rather do math and work by myself. Complementary colors complete colors. So a complementary color would be a color when added to another one makes white light. So you can make white light simply by adding two colors rather than all three, red, green, and blue. So if you were only going to add only going to add two to make white light, one would have to be primary and the other would have to be secondary, because secondary is made up of two, and then you just take the other primary to complete the picture, to have all three then. So for example, yellow would be complementary to blue, because yellow light is made up of red and green, and if you add blue, you have all three of them. What would be complementary to cyan? Well, cyan's made up of green and blue, so red is complementary to that. And then magenta and green would also make white light. A dye is a molecule that absorbs certain wavelengths and transmits or reflects others. We put dyes in clothing, change them colors. They absorb some things and reflect others. The reason something appears a certain color is because it's reflecting that color. A tomato looks red, not because there's red in it, but because it reflects red. So it's going to absorb green and blue light and then reflect the color that we see. Pigments are the same thing as dyes, except they have larger particles. So these particles are large enough that you can actually see them with a microscope. In art class, you're used to pigments. Primary pigments absorb only one color from white light and reflect the rest. So if you can imagine something absorbing one color, if something absorbs red, that means it's going to reflect green and blue together make cyan. So cyan would be a primary pigment. If something absorbs green, that means it's going to reflect red and blue, or magenta. So it's going to appear to be magenta in color because that's what's being reflected. That's what our eyes are going to see. So cyan and magenta and yellow, your three secondary light colors, make up your primary pigments. And if you mix all three primary colors of paint, you actually get black. So mixing primary colors is considered subtractive because you lose light, whereas mixing primary colors of light would be considered additive. Primary pigments would be subtractive, light would be additive. Secondary pigments absorb two primary colors and then reflect just one. So your secondary pigments are red, green, and blue. If you absorb red and green, you're going to reflect blue, and that's what it appears. You see it as blue because that's what's being reflected back to your eyes. So your primary pigment colors are your secondary light, and your primary light colors are your secondary pigments. And just like we had complementary colors for light, if you mix a primary pigment with a secondary pigment, you would end up getting black because you get all three being absorbed. Now there's a website that kind of shows this color mixing. I'm going to try and go to that real quick. This is on Moodle as well. But this is kind of neat. If you take these flashlights And notice if I'm only shining 100% red and green, the mixture of them would be yellow. If I turn off my red flashlight and just add my blue flashlight, the light that's formed is cyan, because green and blue make cyan. If I get rid of my green flashlight, add my red, the mixture is magenta. And you can play around with different percentages here. So 100% of everything we know would make white light right in the middle. Where these two mix is cyan, there's your magenta, there's your yellow. If you decrease the amount of green, you'll notice you start getting your different shades. You can make your orange, and so on and so forth. The more you get rid of, eventually goes to red. You can switch from ink to paint if you want, so feel free to play around with this website a little bit as well. I want to explain one last thing here about these complementary colors. If I have a pigment that absorbs one and reflects the rest, so if I have something that appears, a primary pigment, yellow, is going to absorb green and reflect, just kidding, it's going to absorb blue and reflect red and green. That's why it appears yellow, because red and green combine to make yellow. If you have the other primary pigment, cyan, what colors must be reflected? Well, it must be red and blue, which means it's going to absorb green. Magenta will reflect you know what, I messed up on this guy. Magenta is going to reflect red and blue and absorb green. Cyan is going to actually reflect, you should have caught that, green and blue and absorb red. So green and blue we know make cyan. Red and blue make magenta, so it has to absorb the others. Notice if you mix all three, you're absorbing blue, red, and green. If it absorbs everything, that means there's nothing left to be reflected, and therefore it appears black.